We are back in Unit 1, exploring one variable data. We are in the third part of 1.7, summary statistics for a quantitative variable. So this part's definitely shorter than the others, but super important. So here we're going to talk about the impact on transforming your data. So what happens to a data set's summary statistics if all the data is transformed? So first we got to understand there's a couple different ways you can transform your data. And when we talk about transforming your data, here's our first example. So let's start with addition subtraction. So if we were to add or subtract a constant for all values in the data set. So, maybe we have a data set of a bunch of test scores and we said, oh, we're going to give everybody 5 bonus points. We're going to add 5 points to everybody's score. Or maybe we had a data set where we weighed everybody and we realized, oh, the scale was off by 5 pounds too much. We got to subtract 5 from everybody's weights. So that's what we're doing here. So, and again, another example here is maybe everybody in a company has a salary. We're going to give them all a $500 raise. So everybody's salary goes up $500. So, how is the summary statistics, everything we've been talking about, mean, median, standard deviation, IQR, quartiles, how is all that going to be affected? Well, measures of center, the mean and median, they're going to go up by that same amount. Just think about it. If every value in your data set goes up by 5, then the mean's going to go up by 5. The median's going to go up by 5. The min's going to go up by 5. The max is going to go up by 5. Q1 going to move up 5. Q3 going to move up 5. So measures of center and the other measures of position, like the percentiles, Q1, Q3, they're all going to go up 5. Or if you subtract 10, they're all going to go down 10. Pretty simple. But measures of variability, remember there's 3 ways that we measure how your data varies: range, IQR, and standard deviation. Those will not be affected at all. And that should hopefully be a fairly easy explanation. If you have all of your data, like think of all of your data in a big chunk, okay, here it is. And all of your data collectively together moves up 5. It's not more or less spread out. It's still same spread, it's just moved up. You kind of think of it like this. I know this might be a bad explanation here, but here's all my data clumped up, and I'm going to add 5 to all my data. So all my data now moves up like this. And that's a terrible picture, I know. But again, it's really bad. But again, the spread of my data doesn't change. It just moves up or moves down. The spread doesn't change. So key thing, addition, subtraction of a constant does not change range, IQR, standard deviation. Maybe a better idea would just be to talk about the min and the max. If your min is 3 and your max is 15 and you add 5 to all of your values, your new min is 8, your new max is 20. So the spread of the data is still 12. 15 minus 3 is 12, 20 minus 8 is 12. You're not changing the spread. Maybe that makes a little bit more sense. All right, what happens when you multiply or divide all of your data by the same constant? Well, why would we do this? Well, first off, maybe we're converting. Like we're going to convert feet to inches. If you're going to convert feet to inches, you have to multiply all of your feet by 12 to convert it to inches. Or maybe you're going to go from pounds to kilograms and so forth. So to do that, you got to multiply. All right, so how does multiplication affect your data? Well, simple, it affects everything. Measures of center, mean, and median are going to multiply by that value. Measures of position, percentiles, Q1, Q3, they're going to multiply by that value. And even range, IQR, standard deviation, your measures of variability, they're going to multiply by that value as well. Everything changes with multiplication. So in a nutshell, it's pretty simple. Addition and subtraction of a constant only affect measures of center and position, not measures of variability. Addition, subtraction do not affect variability, range, IQR, standard deviation. Multiplication affects everybody. So let's go back to the data set that we've looked at already a couple times. These are the 13 commute times of 13 women. And we already have all the data that we got here. So we got the mean, standard deviation, Q1, Q3, IQR is Q3 minus Q1, min, max. I actually forgot to write down the median. The median, I believe, was 22. So I'll squeeze that in here. The median is 22. Okay, what happens if we say, oh, there was bad traffic one day and everybody's commute time had 10 minutes added to it? Everyone. So this became a 15, this became an 18, this became a 21. Again, every value had 10 minutes added to it. Well, the mean would become 30.769. The Q1 would become 23. Q3 would become 36.5. The median would become 32. But the min, excuse me, I'm just finished off, I guess. The min would become 15. The max would become 55. But measures of spread standard deviation, IQR, and then range, max minus min, which I could do would be 40. Those are all going to stay the same. Again, because every value is moving up. So it's not becoming more spread out. It's just moving up, not changing the spread of the data. So the standard deviation, the IQR, would stay completely put. Not going to change at all. But if I were, these are in minutes, right? So if I said, all right, so this is all in minutes. I want to convert it to seconds. So to convert minutes to seconds, you multiply by 60. So if I multiply all of this data by 60 to convert it to seconds, well, then every one of these values, every single statistic would be multiplied by 60. Even the standard deviation, IQR, median, everything gets multiplied by 60. Pretty simple. All right, here is another example. So several Amazon delivery drivers were asked how many miles they drive in a month. So every driver had to tell me how many miles they put on their van in the month or their truck. And here are the summary statistics. So here's all of our important data. So let's just say that for some reason, Amazon's doing some type of calculations. And what they want to do is they want to get a new value. And maybe this is going to affect gas prices or, I don't know, salary. Who knows what this is going to affect? But here's their plan. They're going to take all of the old values. So whatever number the Amazon truck drivers gave. I drove 1,000 miles. I drove 900. I drove 2,500, whatever. They're going to multiply it by 3.5 and add 8. So we're going to do both. We're going to multiply and add. So remember, the adding does not affect measures of spread. So I say, well, what's the new mean going to be? Well, mean gets affected by multiplication. Multiplication affects everybody. And it gets affected by addition and subtraction. So the new mean would be 3.5 times the old mean, 1754.14, plus 8. So do that little math there. It's not too complicated. 3.5 times, I'm grabbing my calculator right now as I speak, just to make sure I don't mess that up, because with those fractions, I ain't going to be able to do that in my head. So we get 6147.49. And maybe this corresponds to converting the miles they drive to how much money we owe them. I don't know. Who knows? But again, mean, okay, min would do the same thing. Q1, median, Q3, max, they would all get the same treatment because all those values are affected both by multiplication and addition. But if I said, what's the new standard deviation? Standard deviation only gets affected by multiplication. So I would take the 3.5 and multiply it by 61.0723, and that's it. You would not add the 8. Addition doesn't affect standard deviation. So 3.5 times 61.0723 would be 213.753. Again, can't emphasize that enough. Even if I said, what about the IQR? Well, currently the IQR is Q3 minus Q1. So the IQR is 1806, that's Q3, minus 1704. So the IQR is currently 102. I said, well, what's the new IQR going to be? IQR measures spread. Variability only gets affected by multiplication. So the new IQR would be 3.5 times 102. Do not add the 8. You only add the 8, basically everything else. Right? Just got to remember that variability, IQR range, standard deviation, do not get affected by addition. Everybody else will. So pretty simple there. Pretty common type of question you'll see here in AP. So make sure you understand that. Not too difficult. All right. Now, what happens if we add a new value to the data set? This is where we got to think a little bit. Now, I'm not adding, this is different because I'm not adding a constant to all my values. I'm adding a brand new data set. So any new value added to the data set will affect the mean because it takes all the values into account. So if you have a mean of 23 and you say, oh, I totally forgot to add in another person and that person ended up being an outlier, they were really, really high, then the mean's going to move that way a little bit. Okay? If you have a set of data and you add a new value that's right in the middle of the data, like it's not a weird, it's not really high, it's not really low, it's actually really close to your current mean, then the mean might only change a teeny bit, not really much at all, because it's near the mean. When you add a value that's near the mean, you're not going to change the mean that much, okay? Standard deviation will also change a lot if there's an outlier because remember, standard deviation measures how far data is from the mean. So if you add a brand new value to your data that's really, really far from the mean, the standard deviation has to adjust for it because we now have a new value in the data that's far from the mean. But if you add data that's near the mean, then the standard deviation is actually going to shrink because the standard deviation measures how far data is from the mean. And if the new value is really, really close to the mean, well, then it's going to make the standard deviation smaller so that it can adjust for the value that is close to the mean. The median will not change much at all if a new data point is added. Because remember, the median just wants to be in the middle, right? So, whoa, what the heck happened there? Sorry about that. Got a little messed up there. So, if you have numbers like 1, 3, 5, 7, 22, 5 is your median. If I say, oh, I got to add an outlier, and I forgot to add a value, and that value is clearly an outlier like 87. Okay, now the new median is going to be 7. So it obviously had to move to the right a little bit because now it needed to, again, be in the middle. But again, it's not going to move much. Oh, by the way, I'm actually wrong. It's not going to be 7. It's going to be between the 5 and the 7 because that's 6 values now. So the new median is going to be between the 5 and the 7. So the new median would be 6. Okay, but the point is it didn't really move a whole lot. It moved only a little bit. Okay, whereas if you add an outlier like this, the mean is going to make a major change. Because, you know, without that 87, the mean, again, I don't know what it is off the top of my head, but it's going to be somewhere around the 1, 3, 5, 7, 22. Like, you know, it's not going to be that crazy of a number, but all of a sudden you add this huge outlier, the mean's going to move to the right. Same thing with standard deviation. I'm adding a value, 87, that is far from the mean. So the standard deviation is going to get bigger because that's what the standard deviation measures, how far data is from the mean. So, you know, the idea is if you add values into your data, you just have to know how they affect your data. When you add an outlier, it's going to affect the mean. It's going to affect your standard deviation. The middle of the data, median and IQR, might change a teeny bit, but not dramatically much at all. All right, that's it for transforming data. We'll do some problems and stuff, but it's over not too bad. I will say the biggest thing you got to remember is addition and subtraction only affect measures of center and position, not variability, where multiplication affects everybody. That's some of the key you need to know. All right, that's it.